So let's think about this now, not using vectors and graphs, but let's think about this using plots of position as a function of time. Okay, so this is a document that you can find in our shared drive. It has a set of 6 graphs that are showing the motion of 6 different objects. Now, one thing, if you learn nothing else in this class, here's one thing that I want you to learn. When you look at a graph, what is the first thing you should look at? Anybody have any ideas?
The axes.
The axes, yes. All right, so what is on the horizontal axis for these graphs? I need a bigger highlighter. Wow, there we go. What variable is being plotted on the horizontal axis?
Time.
Time, right. So what we're looking at, say in graph A, is not an object that is being dragged along the floor horizontally, right? We are seeing an object that is, its position is being recorded as a function of time. So algebraically, again, the way that we'd write that is we would say we're measuring position as a function of time. How can I tell that what we're measuring is position? It's the other axis, boom, right? So the vertical axis here is talking about position. Okay, so look at your horizontal axis, look at your vertical axis. That's where your eye should go as soon as you see a graph, right? Sometimes students' eyes are drawn to the line or the curve that's shown on the graph, and they want to kind of jump in and start interpreting that. But that's the wrong way to begin, because if you don't understand your axes, you're not going to be able to interpret that curve.
Brett, I have a question.
Yes.
What's the difference between displacement and distance traveled?
Ah, very good. Good question. Let's see. All right, I think I'm gonna have to punt on this because I'm not seeing the option that's supposed to be there. We'll just do groups the old-fashioned way. But okay, let's see. Let me grab a piece of paper here. Boop. So I'm going to make a different graph than the ones we're about to interpret. So use caution here. I'm going to make a regular old position versus position graph, an X versus Y graph. And if you've got an object and it follows some kind of crazy path, right? Its displacement erases all the information about the path. So the displacement of this object is just this vector right here. And we lose all the information about whether it went left, right, up, and down. All we care about is at one time it was here, at another time it was here. If we are going to measure the distance traveled, then we actually have to go along this path and add up each little segment along the path. Okay, so that so the distance traveled and the displacement in general are going to be different. Okay, great question.
I got one question. So the red is the displacement going across, and then what you like, what you colored with purple, that's the length you said?
The distance traveled.
The distance.
Yeah, so we might say the distance of that is traveled, the length of the path. Those would be vocabulary words that we'd use to indicate that.
Okay, thank you.